So Unit 7, Day 1, before we can actually get into the quadrilateral, we have to just talk about plain old polygons. So today's going to be all about the polygon. So we're going to review this first, third of a page. It's just review. Stuff you should already know, but you may have forgotten because it's been a little bit. All right, so a polygon is a closed, plane figure with 3 or more segments. So when we say it's a closed figure, that means it's not open, like an angle. Okay? So it has to be closed. It can't be open. It has to be a plane figure, which means that it's flat. So it can't be like a cube or a sphere or a pyramid. It has to, or a cylinder. It has to be flat. Okay? It has to have 3 or more segments, which means no curves, right? A circle is not made with segments. Segments are parts of lines, and lines are straight. So no curves. Okay? Once you decide something is a polygon, then you can just classify it as either convex or concave. A convex polygon has all your vertices, all the corners are pointing outwards. So for example, if I were to draw like a little house, right? It's closed, it's flat, it's made with all segments. If I look at all of those corners on that one, there's 5 of them. There's 5 vertices, and they all push outward. So that is convex. Please stop talking. So that is convex. Okay? Concave, for concave, then you're going to have at least 1 or more of your corners that push inwards. Okay? So if I were to take the bottom of that little house, and then I were to take, instead of the roof pointing outwards, if it pointed downwards, now I still have 4 corners that are pointing outward. This one's pushing out, 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 and out, but I have 1 that's pushing in. So that makes this one concave. And the way I like to remember it is, I think, caved in. You have 1 or more corners that are caved in. Okay? Alright, so let's classify these shapes as either polygons or not. If they are polygons, what kind? And if they're not, why not? So the first one. Is this a polygon? Yes.
Polygon.
Convex or concave?
Convex.
Convex. What about the heart?
Yes. Yes. No.
If you're saying no, why not? Because of what? The rounded part, the curved part, right? You can't have any curves. No curves allowed in a polygon. What about the plus sign?
Yes.
Yes? Convex or concave?
Concave.
Concave. I have 4 corners that are pushed in, right? Concave. And what about the last one?
No.
Why not?
Because it's not open.
It's open right here, right? It has to be closed in order to be a polygon. Okay? Alright, when we classify polygons, most of these, you've seen all of these before, and I know you remember triangle, quadrilateral, pentagon, hexagon, octagon, and maybe decagon. But the poor heptagon, we tend to forget the heptagon all the time. That's my 7-sided figure. It depends on if you want to draw it convex or concave. It's easier to draw it concave. To draw a regular heptagon, it's much more difficult. And then you have a decagon, which is 10 sides. You can make that, if it's concave, it kind of looks like a star. And then your dodecagon has 12 sides. Notice I skipped 11. The ones you see here are going to be the ones you are expected to know. If I put the word on the test, you're expected to know how many sides it means. Okay? Any other side, they all have names. So if your favorite number was 38 and you wanted to know what I would call a 38-sided thing, you just Google it. It'll tell you. Everything has a name. they start to get really long and tedious, so we don't bother memorizing them. Anything that is not 3 through 10 or 12, we're just going to use that number hyphens on. So we'd have a 35 gun, or a 13 gun, or a 27 gun.
28.
A 28 gun.
Oh,
Yeah. Okay. A 487 gun.
How many what?
Is that even
that many
possible?
points?
Well, it would look very circular if you tried to make it convex. But concave, if you wanted to make it concave, you would just do this. And then you do it 487 times until you, and then just make sure you close it on that 480 whatever time.
That's like 12.
I don't know how many I just did. It was more than 12.
That's 12.
That's 12. 13, 14, 15, 16, 17, 18. Well, assuming that's straight. 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. 29 guns.
You can't do that.
What?
Why not?
That's like
Okay.
cheating.
Is it flat?
No.
Yes.
Yes.
Is it made with segments? Assuming I had used a ruler and they were straight, right? It's made with segments.
Well, she didn't.
It's closed. So this represents a convex or a concave polygon. We wouldn't really be able to do much with it, but it is a polygon, assuming everything's straight. All right, so it's a 29 gun. All right, now the next thing we're going to look at is the interior angle sum. Okay, and I do have a formula there for you, but I want to show you why the formula works because I think it's kind of sometimes important to see why things are the way they are. So I'm going to show you, I'm going to derive the formula for you. We all know that if we have 3 sides, what shape is that? It's a triangle. All right, we spend lots of time talking about a triangle. Okay, so if I have 3 sides, then I have how many triangles? There's just one there, right? It's not a trick question. I drew 1 triangle. And I know that the sum of the angles in the triangle is what? 180.
Oh, no, I said it last. What exactly?
Okay, so now, if I have a quadrilateral, so I have 4 sides, and it doesn't matter if it's like a regular quadrilateral or something weird like that. Okay, if I have a quadrilateral, it doesn't have to be a square or rectangle. It can be weird. Okay. If I use the fewest number of segments possible and turn this into triangles, how many segments would I need to draw on this to make it into triangles?
Let's see. 4.
I can do it with 1. I said as few as possible, right? I can do it with 1 segment.
Triangle.
How many triangles do I make?
2 triangles.
2 triangles. So if I add up this angle, and then these 2 angles together will make that angle, plus this angle, and then these 2 angles together will make that angle. If I add up all of these angles, it's going to be 180 for these 3, and 180 for these 3. So it's going to be 2 triangles. Each triangle has 180 degrees in it. That's going to be my sum for a 4-sided figure. If I have 5 sides, like a little house, what's the fewest number of lines I can draw to make a triangle, to make
2.
this into a triangle?
2.
2.
Exactly.
I can go here, and then I can go here. Those aren't necessarily the only 2, but those are the 2 I drew. How many triangles do I end up with? 3. And so if this one has 180, this one has 180, this one has 180, I can find the sum by doing 3 times 180. This is the last one we're going to do because I don't want to draw a heptagon.
You draw a heptagon.
There's a heptagon. No, Miss, on the thing, there's a weird heptagon. Oh, yeah, like that. Kind of.
That's a hexagon.
3. 3 lines.
3.
Oh, it wasn't good. That works out.
Yeah. How many triangles?
4. I just
1, 2, 3, 4.
1, 2, 3, 4. Yeah.
So if it's 180 degrees in each triangle, then my sum is going to be 180 times 4. I don't want to draw a hexagon.
You should draw a hexagon then. You should try. 1, 2.
No, this is not going to work.
Now you go in the boot.
No, but it has to be convex. It only works on convex.
You can't make it wider?
Boom. Then make the 2 segments.
Heptagon.
Whoa.
Alright, so how many? How many triangles did I make? So I would do 5 times 180. I mean, as long as I did 7, I might as well do 8 because 8's the easy one. Because it's an exploded square. Connected. How many segments? 5. How many triangles? So 6 times 180. Look at the relationship between the number of triangles and the number of sides. What's the relationship? 3, 1, 4, 2, 5, 3, 6, 4, 7, 5, 8, 6. What am I doing each time? Decreasing by 2. So whatever my sides are, let's say it's n, my number of triangles that is that n minus 2, right? Yeah? Because, right, 3 minus 2 is 1, 4 minus 2 is 2, 5 minus 2 is 3, 6 minus 2 is 4, 7 minus 2 is 5, 8 minus 2 is 6. And then what am I doing with that number of triangles? I'm multiplying it by 180. So if I take the number of triangles and multiply it by 180, that's going to give me the sum of the angles inside that shape. Look at my formula. N minus 2, the number of sides minus 2 gives me how many triangles I can make times 180. So that is where the formula comes from. If you found that enjoyable and you signed up for college algebra, you may enjoy college algebra. If you thought that was a waste of time and you signed up for college algebra on-ramps, I should say on-ramps, then you may not find it as enjoyable. Because that's the sort of thing we like to do, is figure out where our formulas come from and why they work. Alright, so now that we know why this formula works, what is the sum of the internal angles in a hexagon? So if I'm looking at a hexagon, my sum is going to be n, which if I'm a hexagon I have 6 sides, minus 2 times 180. So that's going to be 4, right? 6 minus 2 is 4, times 180. What's my sum for my hexagon? 720. Okay. What about a 14-gon? Here my sum will be 14 is my number of sides minus 2 times 180. 12 triangles times 180. Easy peasy. Alright, number 1, find the value of A. First thing I need to do is I need to know what do all those angles add up to. So how many sides does it have? How many sides do we have?
6.
6 sides. So I know the sum. It's a hexagon. We just did a hexagon. What's my sum going to be for a hexagon? Yeah, we don't have to do it again. We've already done it. From here on out, we can just refer back to here. We know it's going to be 720. If I know all the angles but one, how can I figure out what that one angle is? Angle A. Yeah, add the ones you know together, and then take it away from 720 to see what's left for that missing angle. So I'm going to add the 136 plus the 136 plus the 105 plus the 142 plus the 88. Somebody use your calculator. Tell us what you get. 6 what? 607. And I know that all my angles together have to make 720, so I need to see what's left. What have I not used? So 720 minus that 607. What's left for angle A? 113. Degrees. Alright. Yeah. Alright, now the next one is a little bit more difficult just because I don't have all the angles but one, right? So I'm going to have to do a little bit more algebra on number 2, but that's okay. First I need to know what are they all going to add up to, so I need to know how many sides I have. How many sides do I have?
I don't know. Can I say it?
Uh-huh.
Okay, I know the answer.
5. Everybody already yelled it out, sorry.
Oh, wait.
5.
Oh, no,
5.
That I'm talking about.
Oh, okay. So my sum is going to be 5 minus 2 times 180.
540.
Mm-hmm.
Wait, not that.
Yeah.
Oh, yeah.
So that means if I add all those angles together, they're going to add up to equal 540 degrees. So if I do this, I'm going to start here with 7x. If I do 7x plus 4x plus 5
That will equal 6x.
plus 5x minus 5 plus 6x plus 10 plus 4x plus 10. I know those are all going to equal,
26x plus 20.
hold on,
Oh, okay.
on this side they equal 540.
Oh, okay. Fine.
Okay. Now, Mallet, when I put them together, what do I get?
26x.
Yeah, if I put all my x's together, I get 26 x's.
Sorry.
And then when I put my constants together, my plus 5 and my minus 5 cancel out. So I just have plus 10 and plus 10, so plus 20. Equals that 540. What do I need to do to solve this?
Subtract the 20 from the 540.
Subtract 20. Let's do it on both sides.
Yep.
Subtraction property of equality. Leaves me with 26x
Equals 520.
equals 520.
526 times 520, and you'll get 20.
And I get 20.
Yeah.
So x equals 20. That's not my answer though.
Nope. You gotta go back and
It says to find each angle. So that means I need to go and put that 20 in for every x. So when I do that, what do I get for 7 times 20?
140.
140. 4 times 20
80.
plus 5. 5 times 20,
10.
100 minus 5.
95.
6 times 20,
120.
120 plus 10.
130.
4 times 20
80.
plus 10.
90.
So this I could just put a little box there if I wanted, right? That's the right angle. 90 degrees. How can I check to see if I did my math right?
You add them all up.
Yeah, add the pink ones all up and I should get
540.
540. Very good. Alright, the next one. Number 3. The sum of the measures of the interior angles of a convex polygon is 2340. How many sides does the polygon have? Okay, this one it's real easy to make a silly error when you're doing this one, so I want to really point it out. Okay, we know that the sum equals n minus 2 times 180.
Just have a question.
Yes.
It's 208, I can leave it 210. Is it okay if I leave a little early? Just
Yes,
ready?
that's fine. All right, what's my sum here? My sum is 2340. So 2340 equals n minus 2 times 180. So here I have two options. I can distribute that 180 in and deal with the 180 and deal with the 360, some like big numbers. Have fun, guys. I deal with big numbers. Or if I'm multiplying by 180, if I'm multiplying by 180, what's the opposite of multiplying by 180? Dividing. So I'm just going to get rid of that 180 right off the bat. I'm going to divide by it on both sides. You could distribute in if you wanted to, but I think it's nicer to kind of already get down to smaller numbers as quickly as possible. Somebody use their calculator and tell me what is 2340 divided by 180?
That would be
13? And that equals, I still have what was left in the parentheses, n minus 2. How do I get rid of the minus 2? Add 2 to both sides. So the number of sides is 15. The most common mistake here is to either stop and say the answer is 13, or to say, oh, there's a minus 2, and so then subtract 2 and end up at 11, and then you'll be 4 off in the wrong direction. So make sure that you are doing it in the correct order there. Okay? All right. Number 4, how many sides does a convex polygon have if the sum of the interior angles is 3,960 degrees? So this is the exact same as the last problem we did. My sum, though, is 3,960 equals n minus 2 times 180. What's the first thing I want to do? Divide out the 180 so I can get smaller numbers to work with. Again, you could distribute it in and just get bigger numbers. That would work as well. What is 3960 divided by 180? 22. That doesn't equal n, that equals n minus 2. How do I get rid of a minus 2? Add 2. So how many sides do I have? 24 sides. Questions on any of those? Okay. Let's review what we remember about regular polygons. The stained glass window project you just did worked with regular polygons of side length of 2. So all of the sides were exactly the same. They were all 2 centimeters. And then by that byproduct, each of the angles are the same, right? So all 3 of these angles are the same. And we've already learned what they are in a triangle. They are 60 degrees. And then in my quadrilateral, we know all the sides are the same. I should have marked the sides the same over here. We know all the sides are the same. And we know all the angles here are 90. And then on my pentagon, we know all the sides are the same. And they're different from pentagon to pentagon, right? Because you could have a small one that's equilateral. You could have a big one that's equilateral. But the angles will all be the same, whether it's small or big. And they will all be, well, let's see. We already came over here and we said, I know if I have 5 sides, my sum is going to be 540. So if I have to divide that 540 into 5 equal angles, if I have a sum of 540, when I divide that into 5 equal angles, how big is each angle? 108. So here we have 108, here we have 108, 108, 108, and 108. On my hexagon I have 1, 2, 3, 4, 5, 6 equal sides. We already did on the very first problem and the example number 1. We already found the sum of my hexagon. What was the sum for the hexagon? So if I divide that into 6 equal angles, 120. Look at number 5. Find the perimeter of a regular hexagon A, B, C, D, E, F if the distance from B to C is 3x plus 6 and the distance from E to F is 4x minus 2. So the first thing I'm going to do is draw my hexagon. Draw a horizontal bar and a less than and a greater than and pretend it's regular. Mine's a little squished, but pretend it's regular. When you label a polygon, this is going to become super important with quadrilaterals because it's real common to mislabel them. You pick a corner, any corner. It doesn't matter which one. I'm just going to go up here in the upper left. But you can pick any one you want. After you pick that corner, you have to label like you're walking around the figure, and you have to walk on the segments because if you walk diagonally across the figure, you're going to fall into hot lava and die. Okay? So if I start here with A, I only have 2 options for B. I can put it here or I can put it here, and that's it. So I'm going to put B here. Then from that point, I only have 1 option to go because I can't put C over here because that means I walked across the hot lava, right? So A, B, C has to be here. You have to walk around it after the first one. All right, once I have that, then we can label the expressions we know. So BC, I know, is 3x plus 6. And EF is 4x minus 2. Now, we know it's a regular hexagon, so all the sides are equal, and all the angles are equal. We already found the angles are 120. But unfortunately, this problem isn't working with angles, it's working with sides. So we don't care that the angles are 120. They are, but it doesn't help us. But what do we know about those 2 sides? They're congruent, they equal each other. So my 4x minus 2 is going to be equal to my 3x plus 6. What do I do to solve? Add 2 to both sides. Good. Addition, property of equality. We could have moved the x's, right? We could have done either one. 4x is going to equal 3x plus 8. All right, then what? Minus the 8, subtraction, property of equality. Nope, not minus the 8. Minus the what?
3x.
The 3x. Subtraction, property of equality. So 4x minus 3x is just 1x equals 8. All right, so now if I want to find the perimeter, can I do 8 plus 8 plus 8 plus 8 plus 8 plus 8? Right, 8's not the side, 8 is the x, right? So to find the side length, I have to plug that 8 in. So I have to say 3 times 8 plus 6, or I have to say 4 times 8 minus 2. What's 3 times 8? 24 plus 6? 30. What's 4 times 8?
32.
Minus 2? Which makes sense because we said they were equal. If they weren't equal, we did something wrong, right? So each of my sides, this is 30. That means all my sides are 30. So then my perimeter is going to be 30, and there's 6 sides. So what's my perimeter? 180. And it's real tempting when you see a number like 180 to say, oh, it's 180 degrees. But degrees are angles, and these are sides. So we can't say degrees. We don't know what the units are. We don't know if they're inches or centimeters or millimeters or miles. We don't know. Questions? So far, so good? Okay. What is the measure of each interior angle in a regular pentagon? We already did it. What was a regular pentagon for inside? It was what?
540.
540 is the sum of all the angles. So when I wanted just one angle, we did the 540 and we divided it into 5 equal angles. How big was each interior angle in our regular pentagon? 108. Right, we did it right there. So each of those angles is 108. That's only going to work out if you're working with regular. Right? You won't be able to do that sort of thing if it's not a regular shape. Okay? When I look at the next one is a decagon. So the first thing I need to do is I need to figure out, well, what do all the angles add up to? We haven't done a decagon yet today. So I need to figure out the sum for my decagon first. Which we know a decagon has how many sides? 10. Take away 2 times 180. How much? 8, yeah. 8 times 180?
1,400.
So all 10 angles in my decagon are going to add up to 1,440. If it's regular, so all 10 angles are going to be equal, how do I figure out each angle? Divide. So 1440 divided into 10 equal angles. Each angle is 144 degrees. All right. So now we're going to talk about, we're going to get away from the inside of our figure and we're going to talk about the outside. The exterior angles. It says the sum of the exterior angles in a convex polygon is 360. So notice it doesn't say in a triangle, or in a quadrilateral, or in a pentagon, or in a heptagon, or in a 13gon. It just says in a convex polygon. So that means this is true for every convex polygon, whether it has 3 sides or 23 sides. The exterior angles will equal 360. So let's remind ourselves what it means to be an exterior angle. If I have a triangle that's equilateral, so it's regular, because it's the easiest one to work with, I know that the interior angles are all 60. If I were to extend one side at each corner, those would be my exterior angles. Your exterior angle makes a linear pair with the interior angle. So if I've used 60 degrees on one side of a line, hopefully you agree that that means there's 120 degrees left, right? So all these exterior angles are 120. What's 120 times 3? Oh, 360, which is what I told you it would be, right? Let's say, what if we don't have a triangle? What if we have a square? A square is a regular polygon, a regular quadrilateral, where my angles inside are all 90, which means if I look at my exterior angles, they're also going to be 90 because they're a linear pair. What's 90 times 4? 360. Let's do one more. We're just going to do up to the pentagon. If I have a regular pentagon, and a regular pentagon, you can't draw it exactly like a house. The actual bottom comes in just a hair. And we already did it twice. A pentagon has interior angles of 108. So when I extend each side and I make that linear pair, how big is that angle on the outside going to be? How big is that little angle going to be? 108. It's a linear pair. 72. Right? How many degrees in a linear pair? 180, right? That we learned in Unit 1. I told you when we learned stuff in Unit 1, we'd be using it all year. I wasn't kidding. If I add 72 5 times, guess what I get?
360.
Oh. We could come up and do it with the hexagon also. What's the linear pair to 120? 60. And if there's 6 angles, because it's a hexagon, 6 times 60, 360. Your exterior angles will always add up to 360 degrees. Alright, so now we did triangle, we did quadrilateral, we did pentagon. We just talked about the hexagon. Let's look at the heptagon. Not going to draw it. If we talk about the heptagon, and I know that the angles have to add up to, what did I say they're going to add up to? 360 for exterior angles. If they're regular polygons, that means all of those exterior angles will be exactly the same. So they're going to be 360 divided into however many angles there are. If I'm a heptagon, how many angles do I have? 7. Somebody use their calculator, round it to 3 decimal places for me. 51.429 degrees. For my hexagon, we already did the hexagon. We talked about it anyways. We didn't actually do it. 360 divided into 8 equal angles is going to be how much? Or sorry, hexagon, not 8 equal angles. How many equal angles? 6. I was doing an octagon. Each angle is going to be 60, which we had already looked at, right? Because we know the interior angle is 120, the exterior angle is 60, because together they're supplementary. All right, last one. Find each exterior angle. What do I know all the angles add up to? 360. I didn't even have to count the sides because it's always 360. So I'm just going to take all those angles, the 4z plus the 2z plus, I can't drop those parentheses like I did the other ones because I'm going to have to distribute that 3. So unless you distribute it while you write it down. Plus z plus 96 is going to equal equal 360. Exterior angles always add up to 360. Before I can combine like terms, I'm going to go ahead and distribute that 3. So I'm going to have 4z plus 2z plus 3 times z minus, or 3 times a negative 2 is a minus 6 plus z plus 96 equals 360. Let's combine our like terms, so let's add all our z's together. 4z, 2z, 3z, and z. How many z's do I have? 10 z's. And then my constants, I have a minus 6 and I have a plus 96. So that's going to be plus 90 equals 360. What's my next step?
Subtract the 90 both sides.
Subtract 90 on both sides, my subtraction property of equality. 10z equals 270. And then the last thing I need to do to find z? Divide by 10. And z equals 27. Now, that's not my final answers because it did say to find each exterior angle. So that means I need to take that 27 and I need to plug it into each one of these. 4z, so 4 times 27, how big is this angle? How big is that exterior angle? 108. So it's obtuse, even though it doesn't really look obtuse, it is obtuse. What about 2z? 54. This one looks like it's a right angle. Let's see if it is. What's 27 minus 2? 25. And then 25 times 3? Oh, that's not even close to a right angle. That's acute. It looks right, but it's acute. And then the last one, 27 plus 96. 123 degrees. Questions? All right, your assignment is available for you in Schoology.